Hey guys, so I was talking a couple of days ago about how we were going to be working with a mixture. This mixture is a hazardous mixture, and I have a picture of it here you can see. There are two liquids in it. I'm not telling you what the two liquids are. And then there is red, black, and two silver solids that you might be able to see in the mixture. And the idea is we're going to write a procedure to try to figure out how we can separate this mixture so that way we can test to find out what it is. Well, first off, I wanted to take a look at the different types of substances. So, of course, you may have heard of elements before. Maybe you've heard of compounds, and maybe you've heard of mixtures, okay? Well, an element is something that cannot be separated, such as copper. Copper is the example you might be able to see right down there. Copper is an example of an element. Compounds are two or more elements chemically combined, which means they can be chemically separated, but they cannot be physically separated. And by physically, I mean we can't take a strainer to it and strain out all of the things that we need to. We can't take a dropper and suck some of the liquid out of it. No, it's chemically combined. An example of that is like salt, sodium chloride. And then, of course, mixtures. Mixtures are two or more elements and or compounds, but they're not chemically combined. This means they can be physically separated. That means we can, like in the example of vegetable soup, we can pick out all of the vegetables from the tomato soup, and then we can separate the tomato soup from the vegetables. That is a mixture. That's actually called a heterogeneous mixture. You're not going to have to know that word, heterogeneous, but that is the correct terminology. Versus a homogeneous is kind of like a solution, and an example of that would be tea or maybe even Kool-Aid. You may not know this, but actually you can evaporate the water out of Kool-Aid. So even though it's a solution, we can actually still physically separate it by evaporating. Okay, so we're going to be working with a mixture. We're actually working with a heterogeneous mixture, which means it has a bunch of different things. It has liquids and solids, so it's not completely mixed. And these are all of the materials that you're going to be able to use. You can use a CPUP tray. You can use a funnel. That might be good for maybe funneling out the liquids or maybe the solids from the liquids. A dropper, a pipette, a stir stick, a dropper bottle, plastic forceps, graduated cylinder, a vial with a cap. That might be kind of cool for storing the solids in. Safety goggles, of course. We are working with hazardous materials. One of the materials does happen to be corrosive, which means it can burn your skin. And then a metric ruler. You're probably going to not use the ruler until it's time to start testing to figure out what the materials are. So those are the list of materials, and you're going to have to use all of the materials to make a procedure for how to separate the mixture. So you can see up here the title, Sample Mixture Separation Procedure. This is just an example procedure. In my opinion, it's not very good. I think that you guys can write one that's much better, but it's just to get you guys thinking. Here there are 4 parts to separating the mixture. This person started with separating solids and liquids. Then they went to separating different liquids, separating and cleaning different solids, and then cleanup. Okay, here's what I do like. I do like how they start with put on goggles. You probably need to have some safety instructions in your procedures, and then it probably would be a good idea to go ahead and start with how to separate solids from the liquids. And as you can see here, they talk about the funnel, they talk about the CPUP tray and how they're going to do that. You can come up with your own ideas just by looking at the mixture, figuring out what would be best to separate first. Then they talk about the liquids. I like how they mention the dropper, and they're very specific. They tell where to move the liquid, like where to put it. And then they talk about the solids, cleaning, separating and cleaning the different solids. They talk about the forceps, talk about rinsing the solid. That's really cool. And then finally, they have a cleanup. And you also need to have a cleanup, as instructed not only by me, but something that you need to write so that way someone could come in, anybody could come in and perform this procedure. Okay, so those are just some thoughts and some ideas on how to separate the mixture. I will give you guys some time in your lab groups to look at the mixture and come up with your own procedure, and then we'll correct our procedure, see what we can do to fix it before we perform it. Good luck.